Hi, thank you so much for coming. I'm super thrilled to see all of you. Today, I'm going to talk about how we leveraged GitHub Actions for building and releasing 25 plus Android repositories. Um, what were the challenges before and how we overcame those challenges. So my name is Shrikant. I'm working as staff engineer at at YML, and I had a co-speaker here today, Enrique Lopez, but unfortunately he could not come due to personal reasons last minute. So. Uh, so I'm from YML. So YML is a design and technology company that builds products for our clients. And yeah, so do check out our website. It's really nice animated website. So let's begin. So before we go through the challenges of CI/CD that we had before and the solution that we have, let me explain very quickly what kind of architecture we have right now. So we are, for one of our client, we are building an Android shell app, you can say. So it's a multi-variant, multi-flavor configuration-based application. So you pass India configuration, it becomes an India application. If you pass Canada configuration, it becomes Canada application. So I'll start from the bottom. So all the green boxes that you see here are independent GitHub repositories at the moment. And at the bottom, we have core, where we keep our abstract interfaces and enterprise business rules. On top of that, we have capability libraries. These are shared libraries like network, push, all features would need these libraries. Reusable UI components is where we place all our UI components, so that even if we have at client location, we have like multiple teams scattered across the world. So although like there are so many developers building the application, it still looks consistent using this UI component library. On top of that, we have feature libraries. So the feature libraries uses the capabilities libraries and the reusable UI components to build the feature. So, and these feature libraries are big enough. It's not like one screen per repository. It's like big enough to justify that it should be in its own repository. And on top of that, we have the blue color represents the shell app, which is an integration point of all the libraries. So, so previous CI/CD setup that we had, the client had. So we had Jenkins. So we had implemented Jenkins pipeline in each of the repositories. Some of the repositories were not even using the CI/CD. So it was difficult because there was just one AWS macOS machine to build pull requests, releases, main branch, everything for all libraries. And the shell app was also using the same macOS agent. And there was no mechanism, because the libraries would build an AAR file ultimately, but there was no mechanism to build and publish this AAR anywhere. So developers were manually integrating it into the shell app, which was like too cumbersome. And also no app distribution in place. So QA used to click on the link on the Slack, and they used to download the APK, and they used to test it. So it was pretty bad. So the challenges. So duplicate efforts. So because we had like multiple pipelines rolling out any new feature or even supporting existing features, we had to repeat it in every repository. That was chaotic. Then inconsistent CI/CD practices. Some libraries are using Jenkins, some are not. Some are using just unit test and assemble. The others are using detect and lint. There was no consistency there. Like I said, like if we want to add, say, suppose security check on top of the existing checks, it was not possible. Someone has to like implement it in every repository. And Jenkins, although I love Jenkins and I've used it extensively in the past, but it's sometimes we need some DevOps experts to troubleshoot and debug the failures, infrastructure failures particularly. So there is a dependency there. So sometimes our main branch is broken for few days also, worst case. Lack of centralized visibility, so we don't know what is the code coverage across all the repositories. We don't know whether we are following the best engineering standards or not. Yeah, limited visibility into test coverage. So we enter into the reusable workflow world. So what are reusable workflows? So it's a feature of GitHub workflow. So we analyzed this problem and we thought, like, let's not use Jenkins. We are already using enterprise cloud. We get 50,000 minutes of GitHub Actions. So let's see if we can build it using GitHub Actions here. So in GitHub Actions, we have a feature called reusable workflows, wherein you identify your common steps that you want to perform. You put it in one file, and you put it in a separate repository, call it like a CI/CD infrastructure repository. And all the repositories can just call that file. So all you have to maintain is just one reusable workflow file, and all the repository. It's like one-time setup that you have to do in every repository to say that, okay, use this common reusable workflow to build. So, and it will just take care of that. So the next is what benefits that we have, we get out of the box is consistency. All the repositories will have the same quality checks implemented. It improves efficiency because we don't have to roll out the same feature across every repository. It's just one file that we have to maintain, and simplifies maintenance. So yeah. So how does the reusable workflow should be defined? So here, this is a typical workflow file wherein you create a CI/CD repository. In that, create a .github folder. In that, you can create a workflow folder, and in that, you can put this file. So here, when you define a workflow underscore call, that makes it a reusable workflow file. So you can pass any inputs and secrets if you want. Like, for example, we are passing repository name and branch name that we want to build, and any secrets that you want to pass to it. The caller workflow might want to pass, say, suppose some environment-specific configuration secrets or tokens or something that would be required for the reusable workflow. Once we have defined this, the next part is to define what steps we want to execute in that reusable workflow. So it is defined under jobs keyword. So all these are jobs here, like prepare, assemble, test, publish, and notify. They are all, once they are defined, they'll all be built in asynchronous fashion. So if you want, you can also depend on the previous step as well. So by using the needs keyword here. So I'm saying, like, prepare is the first thing that should be executed. Assemble should depend on prepare. Test should also depend on prepare. Publish will depend on assemble. And notify will assemble on publish. Notify will depend on publish. Yeah, sorry. So now that we have defined the reusable workflow, how to call this reusable workflow? So you go to your library project. There, you define the trigger point. So so in this particular case, the trigger point is nothing but release branch. So anything that is pushed to release branch, or if anything is, if a pull request is raised against the pull release branch, then this reusable workflow will be called. This is like one-time setup that we have to do. And what we are saying, essentially the most important point is this uses. So in the jobs, I'm saying use this workflow file called common release workflow that is defined in central CI/CD repository. It's outside repository, not in the current library, this file. So here, actually, this file can be kept in any repository under the same GitHub org, or it can also be kept inside any GitHub org under the same enterprise account as well, GitHub enterprise account. So, and I'm passing, so using the with keyword, we can pass the inputs and secrets that are required for the reusable workflow. So a little customization also is possible, wherein, say, suppose I'm running this test-related task for all my libraries, and almost all libraries have my UI. UI screens exist, but not in the Android Foundation library, for example. So if my repository name is Android Foundation, I'll skip the UI test cases step. Otherwise, unit test will be executed, the one that you see above, test keyword. So that will be executed for all the repositories. Yeah. Workflow design. So this is so far. This is what this is the foundation of the reusable workflow. What are we using? So here we have a central CI/CD repository. Under that we have like all the library projects that are there. Library projects utilizes the reusable workflow files, like the PRs. So we have multiple reusable files like pull request, main branch, release branches, publish the library, etc. So once these libraries builds, they'll produce an AAR file. That AAR file will be published to GitHub Package Manager. So we never had any repository or Maven implemented before, so we are using now GitHub Package Manager. And the shell app will be pulling the dependencies from the GitHub Package Manager, build the application, and publish it to the Firebase app distribution. All this is done through the GitHub Actions only now. So for libraries, for a typical release branch, how our workflow structure looks like. So first we prepare. So first we check out plus setup. So here it uses, so this action/checkout at v3 represents like I'm using a third-party actions, which is provided, which is used from the GitHub marketplace. Like we have Play Store for our apps, like that we have marketplace in GitHub where developers have created their own actions and published there. So these are like all verified actions actually. These actions/checkout, setup Java, Gradle is also I think verified. So like in Instagram we have like verified badge. In marketplace also there are these verified badge exist. So while checking out, I'm doing like a full clone, not a shallow clone, using fetch depth is equal to 0. Oh, and the next step is set up JDK and set up Gradle. So once I've done the setup, the next is build. So the most important is the command that is assemble release. So in typically command prompt, we said /gradlew and assemble release. So if we use Gradle's build actions, so it will, so this we don't need to provide that /gradlew. That will be taken care by that custom action. So yeah. The next one will be test. So after assemble, we also execute test. So this is with code coverage. The next will be lint. So here we execute detect and lint. Once these are complete, then we execute sonar cube. So the sonar cube will, as you can notice here, continue on error is equal to true. So that means even if any of the steps above fails, Sonar Cube will still continue. So that we can do. Then once we have built the application, run the basic checks, now the next part is if everything passes, the next part will be to publish the library. So we'll go through how the library can be published and integrated into the shell app. So here we have to create inside, say, we go into the library repository, and in that library repository, we create a new file called publish.gradle. We call it as publish.gradle. So there you apply the plugin called Maven Publish. Here I have provided 3 properties, that is get version name, get artifact ID, and get group ID. It's very, I'll show you in next couple of slides. This is nothing but going to be my path of the library. So this is like group ID colon artifact ID colon version name. So that will become the whole path to reach to my, to find that library and pull it from the GitHub package manager. So once you define this, the next part in the publish.gradle is you have to provide a publishing task. It is part of that Maven Publish, wherein you the property that we defined here, group ID is accessed here, artifact ID is accessed here. I'm appending release because it is a release type of build. Version name is, I'm appending version name plus version code. I'll explain that in a bit. And I'm telling that pick the library from this particular location to upload it to the GitHub package manager. So the last is the path to the library. And at the bottom, we have to provide a repositories task, wherein we provide the URL. So the library is going to be uploaded under this particular folder. So in Maven package, there is a YML org is my GitHub org, and inside we have a feature repo name. So that will be the parent where the library will be uploaded. And we have to use the credentials here. It's not a open source Maven, so we have to access this particular file, we have to provide the credentials. And these credentials are nothing but like defined in either local.properties if I'm running it locally, the GitHub username and GitHub key, or I can set it as an environment variable in GitHub Actions. So yeah. So as you can see here, I'm using in here version. I'm saying get version name plus get version code. The version code is nothing but I'm using number of commits happened on that branch. So that is ever growing. So it's like a good way of instead of using timestamp, I like to use the number of commits here, so that if when I'm publishing the library, it will be published something like this. Sorry, I'll go back to that slide again, but it will be published something like this 877, as you can see. So from 877th commit, this particular library was published. And once the library is published, it will be shown on the right side on your GitHub repository in the packages section here. So I'll go back. So this version code we covered. The next is the, this is just I'm setting the name of the library so that I can find it to upload it. So yeah, so once we have set up the Gradle, all we have to do is in the workflow file is just call the publish release. So this Gradle task will automatically be created for your library. All you have to do is just call this Gradle task. That's it. And once you call it, it will publish the library. So yeah, you want to take a picture? Yeah, it's okay. So yeah, here this is the packages where it will be uploaded, and this is actually so I've seen like in Android world we use underscore to append some build information along with version name. But actually, this is more aligned with the semantic versioning protocol, semware.org. So, so that's why we followed this approach. So now that the library is published, we want to utilize this library now. How to utilize is just by declaring the implementation like we do for any library, retrofit, OKHTTP, any library. So there is like a group ID that is yml.feature.feature name, artifact ID, which is feature name dash release, the version information. And next time onwards, I'll just have to keep on updating the version information when there is a new update available. And to access that library, I have to provide the, so what I'm saying is here, check the library under any repository under yml.org. So this library will be found under yml.org parent, and use these credentials to pull the library. So once the publish task is complete, all we have to do is just notify our users. So we can notify using Slack or Telegram or email. Any option is possible. So if I'm using Slack, I'm just calling this bash script wherein we are just passing the status of the build. If it is Telegram, it's again a bash script. All we have to do is just call an API. So now that the library part is over, we have built the library, we have tested the library, we have published the library. Now the next part would be to build the shell app and publish it to the Firebase app distribution. So I'm not going to cover all the steps that are there in shell app. I'm going to cover just the app distribution because the other steps are just similar to library only. So here we are using again a third-party custom action here. So there are two options. So in Firebase, as you know, that there is an API that we have to call to upload the APK to that, and we have to pass the required arguments to that API, right? So all you can do this is like you can write your own logic to upload it to the Firebase, or there are some users who have created custom action to do the same. All you have to do is just pass the required parameters in the workflow file. But but you have to check the security considerations. Like some organizations do not allow non-verified custom actions usage in your application. So if that is enabled, you'll have to implement your own custom action for that. If that is okay for the organization, you can. So this is pretty famous actually. Some 3,000 GitHub stars are available on that GitHub page. So so we are using that. I'm passing the app ID, service credentials, and groups and file, all the required parameters that are required for the Firebase here. So the alternatives are Google Play and App Center. We are using Google Play also, but it is for production app. For internal testing, we are using Firebase app distribution. So in Google Play, if it is alpha is nothing but a private, for private groups, I can use alpha track. Beta will be more public, closed group. And I can, we also, and then that same APK can be further advanced to the production as well. So we also do the staged rollouts. In case of Firebase, we use it for internal testing and crash reports. App Center, we were evaluating App Center versus Firebase. We thought it's the same, like no extra features are there from App Center. So we thought like, okay, Firebase, we'll use Firebase. So if you are using Microsoft-based tools in your CI/CD, probably you can consider App Center as well. It's also solid. So now that we have implemented the GitHub Actions in our libraries, how to monitor workflows. In Jenkins, there is a blue ocean, and it's developers sometimes get scared if it's like if they have to go into Jenkins and find the build logs and understand what is happening. So GitHub, you get there is an Actions tab on the GitHub. It's right in your repository only. If it is so, we are using Dependabot here. So this PR was created by Dependabot for upgrading SonarQube version from this to that. And here, this is a feature of GitHub only. We have not done any special configuration for that. So it tells you like what all tasks we executed, like kt-lint, assemble, debug, and code coverage. And it will also tell us the Gradle version in that. So and this caching will also tell us like how many caches were missed and how many caches were used actually. So that will it's very easy to read this report actually. When it's again it's a PR raised by Dependabot. So this time it is trying to upgrade coroutines test related dependency, but at that time while upgrading it has failed few test cases. So it's very easy, just expand that and understand why that test has failed. So like I said, we use Dependabot for dependency management. So it's a feature of GitHub only again. So all you have to create is a dependabot.yml file and put it side by side to your workflow files. And here we are running it weekly basis. You can execute it monthly basis also, and there are various other variations available. So the alternate way to manage your dependencies is RenovateBot. Dependabot is simple. It's already available in GitHub. RenovateBot is more flexible that it can merge your PRs as well. Dependabot only creates the PR. So RenovateBot, and in case of RenovateBot, you have to actually install the GitHub application of RenovateBot to use that. GitHub for Dependabot, we don't have to do any special steps here. So what is our what benefits we saw, and what are the results that we observed? So it is increased consistency and reliability across all repositories. So we started like we identified that there are repositories that are having zero code coverage. So we started like using Sonar quality gates. We created a plan for these kind of repositories to go from 0 to, say, suppose 2%, 2% to 5%, and some like how we can increase our code coverage, overall quality standards there. We also started using kt-lint for code formatting. Detect we are already using. We are adding custom detect rules now, and we just have to add it once in the CI/CD repository, and automatically all repositories will be scanned against those new checks that we are introducing. So it's really helping us. Time savings due to automation and reuse. Yeah, so no need of any rollouts, duplication of efforts. So in case of Jenkins, typically every developer was spending 6 hours in every sprint for all the 22 repositories that we have. It has reduced to 2 hours now. So these 6 hours includes like why build has failed, create a release branch, like manage the releases, why tests have failed, all these kind of things. But the major portion was like infrastructure, like why macOS is not building, and why do we need to restart it or not, etc., etc. Whereas in this, after using workflows, it has significantly reduced actually. It is still 2 hours. It's because anyway, like there are some test failures, and developers have to like with increased like controlled environment, developers have to like then make sure that they are adhering to all the quality standards that we have, and then that's why those like 2 hours are spent in those kind of activities. So it's a significant improvement in terms of developer productivity. So are there any limitations? So far we haven't got into these this is all theoretical. We haven't got into that stage yet. So environment variables. So there is a there is a reusable workflow, and there is a caller workflow. Caller workflow calls the reusable workflow. If I define any environment variables in the caller workflow, and from the caller, if I'm calling the reusable workflow, it will not pass the environment variables automatically. They are not inherited automatically. So they are all different. So it's not a limitations per se, but it's like a security. I like that actually. You can call a maximum of 20 reusable workflow from one file, and that includes your nested workflow. So you can have like a caller workflow, main workflow that calls a reusable workflow, that calls another reusable workflow internally. All of that actually, I forgot to mention. Whenever you call suppose there is a caller workflow, and then you call a reusable workflow, at runtime it's actually kind of merged here in the caller workflow. It becomes the part of the caller workflow. So that's why probably there is a limit on number of reusable workflows that can go in, that we can use. And you can chain up to 4 workflows in nested. You can chain up to like, you can from one to next to next, I can have like that 4 workflows. We haven't got into that situation yet. Cost metrics, we are using enterprise cloud, so we get 50,000 minutes. And we use Linux machine for Android. So it's like 1 minute, but if we use Mac, it is like, don't use Mac, it's 10x. So, and even if your build takes 1 minute to 1 second, it will still charge you for 2 minutes. So that is like, yeah, if you have proudly reduced the build time from 1 minute 40 seconds to 1 minute 10 seconds, it is still going to cost the same. So yeah, so per minute rates, if based on the machine, it is like we are using 16 GB of 16 cores, so it's like 0.064 per minute charge is there after 50,000, by the way. Oh, sorry. Yeah. So yeah. So for more details, you can look at this pricing related GitHub link. That's it. So please share your feedback if you want, and any questions. Thank you so much.